This is a hard question, and let's say if the four roots are x1, x2, x3, and x4, then our condition is f of x1 is 0, so on and so forth for these values. Now, this condition that we're given is true for all values of x, which means that if I were to substitute it with x1, that this will also be true. Now, the key is, how do I rewrite this so that that input becomes x? So I can replace x with anything. For example, I can replace x with x minus 5. I just have to do it on both sides, because it would still hold true. Since it's true for any x, it's also true for x minus 5. So when I do that, this relationship becomes f of x is, because these two drop out, and then this is 5 minus x plus 5, so that becomes 10 minus x. So all I've done is I've rewritten that condition that was given to us here. Now, how does that help? Well, if let's say x1 is one of the roots, then f of x1 must equal f of 10 minus x1. We also know that if x1 is a root, this is equal to 0. And that tells me that if x1 is one of the roots, 10 minus x1 must also be a root. And remember, they're all distinct, and it doesn't matter which one you call the other root. And similarly, if x2 is a root, then the other one is 10 minus x2. And these are all distinct. And so that's kind of you can call this x3, x4, doesn't really matter. But the roots will have these relationships, and they're all distinct. Now we can get to the answer to our question, which is, what is the sum of these roots? If you add them all up, clearly you'll see that drops out, and the sum is 20, which is choice A. So this is a hard question. I don't think I would have gotten this right under exam conditions. Seeing this approach, I mean, I have seen this in other questions, sort of doing this manipulation, but this is kind of how I've thought about this question. There are probably other ways to do it, maybe easier ways, but this is what I have right now, and I'll update as I kind of figure out other methods to do this same question. So to summarize, the answer is A.